if you're listening to this right now, I know exactly who you are, and I know exactly what you're going through.
It's a stressful time.
Yeah, it really is. You're a dedicated BCBA candidate, and you're just staring down the barrel of the absolute marathon that is the certification exam.
All 175 questions of it.
Right, exactly. 175 grueling, scenario-based questions, plus, those 10 unscored pilot questions they throw in there just to completely mess with your pacing.
They definitely keep you second-guessing everything.
Oh, absolutely.
Right.
It's just this massive amount of information to process. Your brain probably feels like a browser with like 90 tabs open right now, and the pressure is incredibly real. But I want you to take a deep breath, because you aren't doing this alone.
You're definitely not alone.
We're doing a custom-tailored deep dive into your source materials today. And I'm right here in the trenches with you. I've got my flashcards, I'm running on way too much cold brew, and I'm prepping for this exam right alongside you.
Which is the best way to do it.
I think so. I'll be asking the exact same questions you're probably screaming at your textbook right now. And to make sure we don't just study, but actually pass this thing, I brought in the heavy artillery. Sitting across from me is our resident BCBA professor.
Hello. Thanks for having me.
You are going to guide us through these conceptual weeds and hopefully keep us from falling into the traps the exam writers just love to set.
Well, look, the certification exam is a beast. There is no denying that. But it's totally manageable once you start trying to just memorize vocabulary words and start systematically breaking down what the questions are actually asking you.
Which is so hard to do when you're panicking.
Right. So my goal today is to help you filter out the noise, decode the jargon, and really understand the core scientific principles underlying all these scenarios.
I love that.
We're going to break down these foundational concepts so that they become absolute second nature to you when you finally sit down at that computer in the testing center.
That's the dream. And our specific mission for this deep dive is to tackle Domain A1 from the BCBA 6th edition Test Content Outline.
A very important domain.
Yeah, we need to identify, distinguish, and master the 3 goals of behavior analysis as a science. So that's description, prediction, and control.
Because if you don't have these 3 concepts absolutely locked down...
The rest of the foundational material is going to feel like building a house on quicksand, right?
Precisely.
Okay, let's unpack this. Before we even get into those 3 specific goals, we have to define the overarching purpose of the science of behavior analysis.
Where do we start?
Well, based on my notes, the sources say our main goal is to achieve a thorough understanding of socially significant behavior.
Yes.
But the catch is, the only way we do that is by completely excluding our own opinions, excluding personal beliefs, and excluding chance from our analysis. We're on a hunt for what's objectively true in the environment.
That's a great way to frame it. As a science, applied behavior analysis separates itself from other helping professions by insisting on that hard, objective truth. We rely heavily on empiricism.
Meaning no bias.
Exactly. Our scientific observations have to be totally unbiased. Our findings can't depend on what the practitioner feels is happening or what they personally believe about a client.
So no gut instincts.
No gut instincts. Every single effort we make to improve a behavior requires us to measure the occurrence and the non-occurrence of that behavior with strict accuracy. To make sure our biases and mere chance are strict out of the equation, the science uses 3 successive levels of investigation.
Like building blocks.
Think of them exactly like building blocks. Those are the 3 goals we're unpacking today: description, prediction, and control. And we have to start at the very bottom, at the most basic level of scientific understanding.
Which is description.
Right.
So as grad students staring at this outline, I have to be honest, description feels almost too easy, like a trick. Well, the source material defines it as the attempt to objectively describe all variables in an environment. To me, that just sounds like standing in the corner of a room with a clipboard and taking notes. It's just stating the facts, isn't it?
It is stating the facts, but doing so with rigorous objectivity is actually much harder than it sounds, especially in a chaotic clinical setting.
I can see that.
Description is the systematic observation that provides a collection of facts about the observed events. These facts can then be quantified, classified, and examined for potential relationships. It's the absolute bedrock of everything else we do.
Because if you get the facts wrong...
If you can't accurately describe a behavior and the environmental variables surrounding it without injecting your own assumptions, you can't possibly move forward to predicting or controlling it.
I want to bring up a specific mock exam question from our sources because this is exactly where I see my classmates getting completely tripped up.
Let's hear it.
Okay, so this scenario is about a researcher named Tracy. It says Tracy is conducting behavior analytic research using an ABA design. Prior to the initial baseline phase, Tracy conducts observations with the participant and establishes clear operational definitions of the target behaviors.
Okay.
It asks, at this point in the study, which level of scientific understanding appears to be achieved. And the options are A, design, B, description, C, control, or D, prediction.
And what's your first instinct?
Well, when I read that, my brain sees the phrase ABA design and baseline phase, and it immediately screams control.
Right.
Because she's setting up an experiment, right?
Yeah.
So she must be at the highest level.
And that right there is the classic trap the exam writer set for you.
That's all I mean.
They throw in advanced terminology to see if you'll lose focus on what's actually happening in the moment. When you read a prompt like that, you have to ask yourself, what has Tracy actually accomplished so far?
Well, the prompt says she's conducting observations and establishing operational definitions.
Exactly. And let's quickly clarify what an operational definition is, just so we don't gloss over the jargon.
Please do.
An operational definition means describing a behavior in such specific, objective, and observable terms that anyone reading it would be able to identify the behavior if they saw it.
So you aren't saying the client was frustrated?
Right. You're saying the client furrowed their brows and slammed their fist on the desk.
Got it.
So going back to the question, Tracy is just defining what the behavior looks like. She hasn't identified any patterns or correlations yet. She certainly hasn't manipulated any independent variables. Therefore, Tracy has only achieved the initial level of scientific understanding, description.
Oh, and option A, design, is just a distractor, right?
Yes, that isn't one of the levels of scientific understanding at all.
Wow. Okay, so you really have to read the verbs in the scenario. What is the person actively doing in that exact snapshot of time?
Exactly. Focus on the action.
To really ground this, let's pull in a clinical example from our study guide sources, because I think a lot of people listening can relate to a chaotic Tuesday afternoon session.
We all been there.
We have a preschooler named Jessica, and she's engaging in disruptive, screaming behavior in her classroom. If we're acting as the BCBA, and we're functioning strictly at the description level, we're acting like a detective, just gathering the initial clues at a scene.
That's a great analogy.
We just state the objective facts. We define the topography of the behavior, meaning what the scream actually sounds and looks like. Maybe it's a high-pitched vocalization lasting longer than 3 seconds.
Good operational definition.
Thanks.
Mm.
Then we count it. Jessica screams, on average, 15 times per day in her preschool class. However, we also note the environment. She doesn't scream when she's on the playground.
Oh.
When she's on the playground, minimal to no demands are placed on her, and she just chooses how to spend her time. We aren't making any grand theories yet. We're just observing the board.
At the description level, you're just taking an objective snapshot of the environment. You have the topography, you have the frequency, 15 times per day, and you have the environmental conditions.
Right.
You aren't jumping to the conclusion that the demands are causing the screaming. You're merely describing the variables present.
But obviously, we can't just stop at description. We don't want to just stand there with a clipboard forever. We want to actually help Jessica.
Of course.
So how do we move from just observing the screaming to actually anticipating when the next meltdown is going to happen? Taking our detective metaphor a step further, how do we go from gathering clues to actually naming a suspect?
That brings us to our second goal, prediction.
Prediction.
Yes, prediction is the next logical step. Prediction is the use of those initial descriptions to identify correlations between different events. We're looking to see whether certain events seem to repeatedly occur within temporal proximity to one another.
Let me pause you there for a second. Temporal proximity. For anyone whose brain is fried from studying, that's really just a fancy way of saying two things happen really close together in time, right?
Yes.
Like seeing a flash of lightning and then hearing thunder a second later.
Precisely. When two events consistently cover, meaning they happen together or in a predictable sequence in time, we've established a correlation. What's fascinating here is a point pulled directly from the translated Cooper text in our sources.
Oh, the Cooper text. The Holy Grail.
Indeed. It notes that prediction with a degree of certainty is a highly prized outcome in science because prediction makes planning possible.
That makes total sense.
If you can predict a behavior, you can begin to arrange the environment to prepare for it, to mitigate it, or to keep people safe, even before you've proven exactly what the root cause is.
Let's apply that to Jessica in the preschool. We've got our baseline description. Now we want to move up to prediction. Based on our observations over a few days, we start to notice a real pattern.
What kind of pattern?
We can formulate a prediction that says, When demands are placed on Jessica in the classroom, like telling her it's time to clean up or sit at the table, she's highly likely to scream.
Okay.
When no demands are placed on her, like during free play on the playground, she's highly unlikely to scream. We're noticing a strong correlation between the environmental variable, the demands, and the behavior, the screaming.
Right.
So as a BCBA, I'd say we solved the mystery. The demands caused the screaming.
Hold on. Don't rush to close the case just yet. That's a vital distinction for you to remember on test day. Correlation does not equal causation.
Wait, really? But they happen together every time.
Yes, but just because the demands and the screaming occur together in temporal proximity doesn't definitively prove that the demands are the sole cause of the screaming. There could be confounding variables at play.
Confounding variables.
Other factors in the environment that you might not be tracking, but they're secretly influencing the behavior? For example, what if the classroom is also incredibly loud and echoing during demand times, while the playground is open and quiet?
Oh, I see.
What if she's seated next to a peer she dislikes every time she's given a worksheet? Prediction tells us a relationship exists, which, again, is incredibly useful for planning, but it completely falls short of ultimate scientific proof.
Okay, my mind is a little blown. So we have a primary suspect, but we don't have enough evidence to convict them in court yet.
That's a good way to look at it.
Here's where it gets really interesting, because as behavior analysts, we aren't just in the business of predicting behavior so we can brace for impact. We're in the business of changing behavior to improve lives.
Exactly.
And that requires the third, final, and absolute highest level of scientific understanding.
Control.
Control is indeed the ultimate goal. In our science, control occurs when an observed correlation is actively manipulated through experimentation.
Actively manipulated.
Yes, this is how we demonstrate what we call a functional relationship.
Yeah.
We need to verify that the dependent variable changes when and only when we manipulate the independent variable. Quick jargon check for the listeners. The dependent variable is the behavior we're measuring.
Here.
Right, because it depends on the environment.
Correct.
So in this case, Jessica's screaming. And the independent variable is the intervention or the condition we, as the analysts, are independently controlling. So the demands.
Spot on. If the behavior changes repeatedly under certain conditions, when we turn the independent variable on, and it doesn't happen under other conditions, when we turn the independent variable off, we've established experimental control.
Okay, let's walk through exactly what that experimental manipulation looks like for Jessica, because this is the stuff that actually shows up on the exam.
Let's do it.
We hypothesize that demands are triggering the screaming. To prove functional control, we have to test it. We can't just watch anymore. So we set up a condition where we withdraw all demands in the classroom setting.
Removing the independent variable.
Right. We just let her play with blocks at her desk. When we do that, Jessica's screaming drops to near zero levels. But we can't just leave her playing with blocks all year. We have to prove the relationship. So we reintroduce the demands.
We tell her it's time to put the blocks away and do a puzzle.
And the screaming immediately resumes.
And that withdrawal and reintroduction is the absolute essence of experimentation. But we have to emphasize a critical detail from the scientific literature here.
What's that?
Doing this just once, turning the demands off and then back on, might still be a result of chance. Think about it. If you flip a light switch once and the room lights up, maybe the switch works, or maybe the sun just came out from behind a cloud at that exact second.
Oh, that makes sense.
To truly demonstrate experimental control, the behavior analyst must replicate the process. Replication is what proves reliability.
Our study guide explicitly mentions this. It says, if we repeat this experiment, adding the demands, removing the demands, adding them back again over several sessions, and the behavior consistently matches our prediction every single time, then we've firmly established functional control.
Exactly.
We've proven beyond a shadow of a doubt that the independent variable is the sole reason for the change in the dependent variable. So what does this all mean?
It's a huge deal.
Why do we have to be so incredibly rigorous about proving this? Why not just stick with our gut feeling from the prediction phase?
Because it means everything for your future clinical practice and the well-being of the individuals you serve. Achieving experimental control is what allows you to say, with absolute scientific certainty, that your specific intervention is the reason a client's life is improving.
Not just a coincidence.
Right. It means you aren't relying on guesswork, you aren't falling for clinical fads, and you aren't practicing pseudoscience. Proving functional control validates that the principles of behavior analysis are actively working to help your client achieve socially significant outcomes. It's the difference between hoping something works and knowing it works.
That's incredibly powerful. It really elevates the work from just trying things out to functioning as an applied scientist in the real world.
It does.
Now, I want to pivot to the strategic side of things, because at the end of the day, you, listening right now in your car or at the gym, have to sit down and pass this massive exam. Let's talk test strategy.
Always a good idea.
Domain A, Behaviorism and Philosophical Foundations, makes up 5% in your total exam. Out of 175 questions, that equates to about 8 questions.
Which might not sound like a lot.
Exactly. 8 questions might not sound like a lot to sweat over, but here's the secret. These foundational concepts are baked into the DNA of the more complex scenario questions later in the test. If you don't know the difference between prediction and control, you're going to completely misinterpret the advanced experimental design questions in Domain D.
That's an excellent point for candidates to realize. The exam writers will test your foundational knowledge by embedding these concepts into highly applied scenarios.
Right, they hide them.
You're rarely going to get a flashcard-style question that simply asks for the rote definition of description. Instead, you'll get a scenario exactly like Tracy, the researcher, and you'll have to deduce the level of scientific understanding solely from her actions.
Exactly. So, since we're in this together, I want to share a memory trick I developed while grinding through these sources to keep this straight on exam day.
Let's hear the trick.
It's super simple. The second you sit down at the testing center and they hand you that laminated whiteboard and dry erase marker, I want you to write down the letters DPC, just DPC. First, D is for describe the what. This is your objective observation. You're just writing down exactly what the behavior looks like and what the environment looks like. No guessing, no theories, just the facts.
Describe the why. I like that.
Next, P is for predict the when. This is where you're finding correlations and looking at that temporal proximity. You're noticing the patterns. When X happens, Y usually follows.
Predict the when.
Finally, C is for control the why. This is the highest level. You're actively manipulating the variables to prove a functional relationship. You're turning the independent variable on and off to prove why the behavior is happening. DPC, what, when, why.
That's a highly effective mnemonic device. And to build on your DPC trick, I'll offer a final practical exam tip based on how these tricky questions are structured in the source material.
Please.
When you're reading a scenario question, aggressively look for the presence of manipulation. Highlight the verbs in your mind. If the behavior analyst in the prompt is just watching, recording data, or defining a behavior, just like Tracy was, the answer is description. If the analyst is looking at a scatter plot and guessing what will happen next based on observed patterns, the answer is prediction.
Looking for the when.
Exactly. But if the analyst is actively turning an intervention on and off, like withdrawing and presenting the demands with Jessica to see the direct effect on the behavior, they are demonstrating control. The active manipulation of the independent variable is your absolute key to identifying control.
That is a golden rule right there. Look for the manipulation. If they aren't turning a dial, it isn't control. Wow, we've covered some serious ground today.
We really have.
We started by looking at the core mission of behavior analysis, which is to objectively understand socially significant behavior without letting our biases get in the way. We walked through the foundational level of description with Tracy the researcher and learned not to fall for buzzwords.
The ABA design trap.
Exactly. We moved up to finding correlations and temporal proximity with prediction. And we finally reached the ultimate goal of verifying functional relationships through experimental control, proving it by turning the demands on and off for Jessica.
A very solid review.
Keep that DPC framework. Describe the what, predict the when, control the why, front and center in your mind. Mastering these 3 levels isn't just a hurdle you have to jump to pass the exam. It's literally the blueprint for becoming a highly effective behavior analyst. Thank you so much for breaking this down with us today and keeping us sane.
Glad I could help. If we connect this to the bigger picture, I want to leave you with a profound thought pulled directly from the Cooper text in your sources.
Okay.
The evidence of scientific control surrounds us every single day in technologies we take completely for granted. Think about pasteurized milk, the flu vaccines we receive, and the very cars we drive.
We don't even think about them.
No, we don't. But all of these modern marvels exist because scientists sought out and achieved experimental control over variables in physics and biology. They didn't just describe or predict, they manipulated and controlled. If the scientific goal of control was powerful enough to literally build the modern world, I want you to imagine just how incredibly powerful it will be when you master it to shape, support, and profoundly improve the lives of the individuals you'll serve in your clinical practice.
Let that sink in. Keep studying, keep grinding, and remember why you started this crazy journey in the first place. You're going to crush this exam. We'll catch you on the next deep dive.